Hello, welcome back to More Fun Fixing It. I promise I will repair that C64 silver label soon. But in the meantime, we have, well, I'm going to repair one of these. I don't know which one yet, but these all came to Paul, Universal Retro Boss, my supplier, together in a single package. And he's written dead package on each one of these. There might be another one somewhere, but I'm not sure. And basically all of these have been worked on. They've all got very similar bits going on inside. If I take these two as an example, all of the ULAs have got heat sinks on and they've all been recapped with these black axial capacitors. This one's only a 16K, it's had its memory robbed. In fact, those sockets aren't flat in there. They've not been installed very well. And this one is full, well, it's got the full 32K upgrade. What else? This one's got socketed ROM. They've all got composite mods done to them, but apparently they're all dead. So this is an issue 3B. I'm favouring this one because it's got no memory here, so that simplifies things a little bit. So maybe we'll try this one, which it's already labelled itself number 3. Oh, that one's number 4. So that one went with there, and that one went there. So this one's favourite at the moment. We're just choosing one for now. That one's in issue 2, so that's out of the running. This one, number 2, is in issue 3. It's got a Murata type switching voltage regulator thing there. It's missing 2 logic chips. It says on here, C6LOU, oh, colour issue. Okay, that sounds boring, but that's a possibility. And there's no screws in any of these. Well, there might be in that one, but that's why these are all held together with lackey bands. Now I'm discounting that one. Let's try this one. This one's another issue 3B. It's got the normal voltage regulator and heatsink. A -6 ULA. What was the ULA? Oh, we don't know. This one isn't heat-synced. Heat-sunked. Has no other chips in sockets and the original caps. And it's number 1. This is in the running. This one's in the running. Let's try. This has got screws in. Just a few screws. Oh, it's a 4S. Okay, and it's got a Traco voltage regulator here, switching voltage regulator, -7 ULA, nothing else in sockets, original caps, no modulator can. The mic, is it the ear or the mic? I can never remember which way around. No, the ear socket is broken. It's actually broken off. I've just lost a leg. Hang on. Goes in there. Missing a speaker. And it's got a big copper shielding sheet behind it that isn't insulated. Look. My God. This is how good an idea this is. This is conductive. I can show you that. Copper, it's a pretty good conductor. Yeah, that's a dead short across there. And you can see here that the back of the, in fact, I can see loads of points where this has had the pins on the back here pressing into it. Loads of them, but especially this keyboard connector here, which is this one here, has got nice long legs on it, and they've been pressing into that copper, so that would have just been shorting out. What a massively useless piece of, well, oh, unless they put a sheet underneath it when they originally, but even then it would have gone through it with these pins. So anyway, this one, the CPU has been changed on this one. I quite liked the look of this, because if this is shorted out, this could be quite interesting and fun. Oh, which one to do? Which one to do? Right, let's try this one because it's a 4S and I quite like a 4S. It's got this weird TR4 position here. But it's not going back in this case with this piece of copper in it. Oh, that's quite thick. What a shame. I have got other cases actually, because this is now, that's bowed on the back. I don't know if you can see that, but it's actually bowed out here. I'm not sure why. It might just be the glue that's deformed the plastic, but yeah, that's going in the bin. It's Christmas at PCBWay. Yes, PCBWay have their new Christmas promotion running and you can grab some limited first come first served Christmas coupons. You can also get up to 50% off 3D printing and CNC machining and some incredible deals on PCB prototypes, PCB assembly, advanced PCBs and whatever FPC rigid flex is. Perhaps the most interesting thing for me in this promotion is a free upgrade to purple, matte black or pink, those most Christmassy of colours, solder masks for your special Christmas projects. You have until my birthday on the 31st of December, I'm sure this was intentional, to fill your Christmas stockings with all of the PCBWay goodies. Link in the description. Merry Christmas, PCBWay. I think I did that with dignity. Before someone cuts themselves. Oh, it looks like the, I was going to say that the membrane might be in good condition. It looks good on that side, but this side, the traces look very black. So don't give that the best chance of survival. Right, let's get these two out of the way. Don't worry, you'll be seeing all of them soon enough. Right, let me get prepared. Okay, this is what I need. Well, I won't need to test the voltage regulator because it's got, oh, I was going to say it's got a traco, but okay, I need a microscope. Okay, that's the other side of the voltage regulator. That I mean, they're not very easy to remove. What usually happens, let me get something to point with, is this trace here, this one here I think is ground, must be ground, and this one is the output, the 5-volt output, so that's on a heavy trace. This one is the input, the 9 volts or whatever coming off of this is usually about 14, so that's got a heavy trace. They've all three have got heavy traces, but you can see that this is actually lifted up here. That's going to need some repair work, but yeah, that pad is gone and that pad is gone and this one is probably gone, but it's hidden under this massive blob of solder. So yeah, that might need some work. I wonder if this was worked on at the same time. I'm just going to check. It's not too bad. It's just quite fluxy. There's bits like that that might be hiding some damage, but that looks like just old flux to me. This is a legacy repair, more likely. No other chips on the back of this have been touched. There is some residue around here though. This doesn't look, well, that shouldn't be there. It's probably something spilt. Anyway, let's do our checks. Right, so I'm going to do from the ground to the voltage rails on the lower memory. Okay. 2K. 3K. That's all. That's okay. And I'll just check the coil. Hopefully that will disappear on this way. No, something's wrong here. Okay, so we've got a C22368 in TR4. And I won't know. I'm actually going to go back to my old multimeter for this. I won't know if this is faulty from the readings unless it's like a dead short. So the reason I've gone back to my old multimeter here is because the diode readings on this are different to that Bryman one. And I just know what these are supposed to be. That doesn't look right. What I would expect on here with the black lead in the middle is a normal voltage drop on both sides of about 0.6 or 7 volts. But this is 0.659 on the top contact and then 0.936 on the other one. And then with the red lead in the middle, we've got 1.4 and I'd expect nothing there and nothing there and 2 there. So, but this is a different transistor than is normally. It's not the normal ZTX 650 that's usually found here. So I'm going to have to pop this out and test it out circuit, I think. Now I've got on the workbench here, you can see the old Duratool ZD915 under testing, and I would normally, if it was the Hacko, I'd just switch it on and use the Hacko to get this out. But that thing is so noisy. It's not ideal to record with, so I'm just going to use the manual pump for now. If I need to take any chips out, I'll do that with the ZD915, which is actually working really well. To be honest, you don't really need a power desoldering pump to get rid of a little transistor like this. It's not actually that difficult. So the curved side was to the left on this one, but there are 6 pins down here. Actually, I can show you with a microscope. Okay, so these 3 that have got no soldering are the ones where this transistor was, and these 3 are alternatives. I'm pretty sure that if I put in an equivalent of the ZTX 650, I can put them in here, but I'm going to have to work out what the pin out is. I can never remember. I might have a board with this, with a ZTX 650 in to compare it, but anyway, let's see if this works. If this works, this will go straight back in. No, it's a diode. It's a broken transistor. Yeah. Okay. Right, so I need to work out how that works then. So I did a quick Google and cheated, and I found a blog post from Tynemouth Software. Brilliant blog style website with loads of great repairs, and a really nice person as well. And they had the same thing where this exact same transistor had blown. Some other problems as well, and I should actually just examine some of the capacitors, because on that repair one of them had actually exploded. Anyway, he had to remove this transistor and replace it with one of these ZTX 651s, and this does go in the alternative points with the curved face to the outside of the board. So let's just get those holes cleared. Pop that in there the right way around. This transistor has caught me out in the past. Somebody asked me to repair a Spectrum for them, this issue board, a long time ago when I very first started doing ZX Spectrum repairs, and I slipped up on this and actually sent it back saying I couldn't fix it because I'd put the transistor, the ZTX 651 in the wrong holes, and the whole thing just would not work. When I finally realised what I'd done, sometime later, I messaged them and said, you need to You need to swap that transistor out of that hole, that set of holes into the next set of holes, and it should work. Right, let's see if that has helped with the problems we were seeing. Actually, let's go back to this one. So it should give us some better readings. So black lead in the middle here. Nothing, nothing. Red lead in the middle. Voltage drop. A nice healthy voltage drop. Oh, come on, slipped off the leads thing. Yep, both ways. So if I go back to resistance, I should get, we do the other way around. Oh, so we shouldn't be getting that. Maybe that might be something to do with this traco though. That's a possibility, but I am still a little bit concerned about switching this on. So what I'm going to do is, or first of all, I'm going to try it with the bench power supply. Oh, yeah, it's current limiting. It is current limiting. So have we got any voltages? 12 is missing. Because this ULA is in a socket, I'm just going to pop it out. Doesn't need to be in there. Everything else is cheap and replaceable. Right, we need to check TR5 next. It's giving normal readings. I don't think TR5 is the issue here. I think it might be capacitors. I wonder if I should go over it with my ESR meter. Okay, and that's what I normally find on this sort of thing, that the caps are actually okay. Or, you know, testing in circuit. This is pretty good at that sort of thing. I know some people say you should not use, or you shouldn't test caps in circuit, but it does give a really good indication of any imminent problems. This is pretty good as well. This little meter. See, that's showing 900 megohms across that cap. See, that's some kind of normal reading, but yeah, that's not a normal reading. Same cap, different revision board, but no, that's just like 1 ohm. That's a really good cap, that one. They're replaced, so that I would expect them to be good. But this one, (975 megohms). That could be the actual issue. Okay, I'm going to recap it, and I'm going to turn this on. Now this is the modified ZTX ZD915. It hasn't got as good thermal mass as, say, a Hacko. But it's got really good suction now. was one of these, wasn't it? Ugh, I can't remember which one it was. Yeah. 900 megohms on that. That's not right. Well, that one's 900 megohms as well. Hang on. There's a brand new cap. 1 ohm. Yeah. This needed recapping. Right, while I've got no caps in at all, I'm just going to see what this does. Oop. Right, that was just drawing 600 milliamps and it wasn't voltage limiting. So I'm fairly confident this was down to the caps. Let's get some new ones in there. Let's see if that's made any difference to the voltages. I'm going to put the Steam Card Pro in, so I'm looking here for the voltages. Yeah, still missing 12 and 5. Something has gone badly wrong here. I'm wondering if I've still got this transistor in the wrong way. Or could it be something to do with this Traco? Although it shouldn't cause any problems because everything looks connected and nothing. I don't think anything's shorted. That should be connected to that. That is the 5-volt rail that's connected. So what voltages are we missing? -5 and 12. So we've got 9 and, which is obviously correct. 5 volts is being provided by the Traco, but the -5 and the 12 volts are being provided down here. And I'm not 100% sure about this transistor here. I'm going to need to do some more research on that. Okay, so I've done everything I can. I've changed the all of the caps. I did put this one in the wrong way round, but that didn't make any difference because the problem that we've got is the -5 and the 12 volts is missing. So watch here. I'll just turn it on briefly. -5 and 12 volts is missing. Now, that is generated around the TR4 and TR5, or the voltages go through TR5 first and then through TR4, and after that, -5 and 12 plus 12 are magically generated. +5 comes from the Traco, but the +12 and -5 come from TR4 and TR5 in that area. I can show you quickly on this schematic. I don't pretend to understand exactly how it works, but this is where the voltage regulator is, and +5, so +9 comes into there. It also goes into one side of the coil as well, plus the +9 straight off of the incoming power supply. Comes out of the voltage regulator as +5 and into TR5, and it's magic happens between TR5, the coil, and TR4, and then coming out of there we've got the +12 volt rails and the -5 volt rails. So there's also a -12 volt. I don't even know where that goes on the board or what it's used for. I think it only goes to the edge connector. But the point here is that I've checked everything in this part of the circuit, all of these diodes, and I've changed the electrolytic capacitors that are all around this part, and I've checked for any problems. There aren't any. Now, the +12 and the -5 are used, well, the +12 is used in two places. The +12 is used in the LM1889N here, but it's also used in all of the lower RAM. And the -5 is used only in the lower RAM. Now, the only thing that I can see that it might be a problem here, when I turn this on, and this isn't something I would recommend anyone do, But I was kind of at my wit's end. Is some of the lower RAM, when left on for a few seconds, I've only left it on for a short bit, so we've got chips 2 and 3, 5 and 7 have started to heat up. That could be completely natural because, well, the -5 and the +12, I'm pretty sure, are the bias voltages. If they're not there, then the chip will just go into meltdown. Could just be that happening. But I'll just turn that on. This chip, I think 2 and 3, these two here were getting hotter than the rest. I want to pull one of these out. Normally, what somebody would do in this situation is actually snip the legs. A tech from back in the day and certain techs these days would just snip the legs. I don't like doing that. I can remove these without risk of too much damage anyway, and the chips might be fine. So I'm going to do that. I'm going to actually pop these out, these chip 2 and 3 out, which is IC 12 and 11, and test them out of the board. Because I think one of these is actually gone completely and is collapsing the voltage, dragging it down. That's my hope anyway. I don't think these are going to move. I could risk it, but I'm not going to. Chip tester. Okay, right, 4116 chips. Go in this side. Yeah, dead straight away. And dead straight away. That's quite interesting. I wonder if that's made any difference to... I mean, there's a good chance they're all gone. It's not current limiting anymore. That is quite interesting. Let's have a look. Oh. Well, it's not current limiting anymore, but there's still something killing the 12 and -5 volts. So I'm going to, the ones that were glowing were 2, 3, 5 and 7. So I'm going to take out 5 and 7 now as well. And I've got a feeling I'll be taking all of these out. I reckon the whole of the, all of the lower ramp is dead. I'd be surprised if any of it survived. Right, 2 more for the tester. Yep, dead. This was the 5, this was IC 9, also dead. Now, is there any chance any of these chips are going to be working? Not so sure. I think they're all dead. Oh, we have all the voltages. And it's not current limiting. But nothing is running. Oh, it's because there's no ULA in it. What did I do with the ULA? Has anyone seen a ULA? There it is. It's a -7 ULA. I'd expect this to be okay. It's not running. We got anything on capture? No signal at all. What? that doesn't seem likely. I've just confirmed on the other screen that there is absolutely zero video output on this. Oh, well, that's voltages has just disappeared again. So, okay, I think it's time to take all of these out. I think that's the sensible thing to do right now is pop all of these chips out and test all of them, because the likelihood is that if 4 of them are damaged, then the others are going to be as well. They're not too difficult to get out of this board. This is quite a nice board to work on. And I've got my method quite nicely set up now, so I just reflow each pin, try and straighten it in each hole so that it's as upright as possible in the center of the hole and has fresh solder on it. And then I desolder with the desoldering gun, not worrying too much about getting every pin loose. It just seems a bit of a wasted effort now, trying to free every single pin individually. It'd be nice if they came out, but then I just pop some hot air on the top and wiggle the chip free, and it comes out nice and easy without any damage. I definitely need to clean that out soon. That's completely chocker. Right. Dead. Oh, we got a live one. Hey, got one live one. Another one. Oh no, that one's half dead. Okay, another live one. So let's put those 2 over there. Does it hold its voltage now? Yeah, looks like it's stable now, but there's still more problems. Okay, so we've got a couple of working chips, a couple of semi-working chips. I'll test them all again in a minute just to make sure that I'm not missing anything. But with no RAM in there now, I'd still expect there to be a video output. So let's try that first. Yeah, absolutely nothing. No video output whatsoever. Okay, so back to basics. So what is working and what isn't working is now I can leave it on without worrying too much about things melting. I can check around first of all for voltages on the board. I know it's telling me these voltages are here, but these aren't exact. And that 9-volt one is slightly dimmer than the other one. So I want to make sure that I've got good voltages on the board before I put any memory in here. So this one, that's -5 is good. And the +12 is 20 volts. And the +5 is 8 volts. So that's really bad. What on earth is going on? What on earth could be causing that? Kind of regretting putting the ULA back in now. I should have checked the voltages first. And this is one of the weaknesses of trusting something that's just showing you whether something is at least a certain voltage. And I shall be more careful in the future. 20 volts. I'm in danger of hurting my Steam Card Pro, actually. Well, the only thing I can think of is that TR4 has blown again because of the shorts on the on this memory, and I'm going to pop it out again and test it again. No, that looks okay. So poking around, I couldn't really find very much, but I did notice that when I was measuring the voltages briefly, switching on and off, sometimes it would be high and then sometimes it would just be like 1 volt. And then, so I just checked the pins on the back of the DC power jack on the back coming into the board, and you can see there that they are moving around quite freely. That's not going to be helping anything, so I need to reflow those. I'll hold it. I still don't think that's going to solve the problem, though. I think there's something more deeply wrong here that I'm not seeing. I have actually changed TR4 again in case it was blown. Yeah, those voltages look too high again. Now that we've got consistent voltages, this is the 12 volt rail. 20 volts, that's wildly high. And 1 volt on 5 volts. Minus 5 volts. Oh look, it's disappeared again now. And it's back. Minus 5 volts. Plus 20. There shouldn't be anything connected to this, actually. I need to check. I think it's like that pin there, actually. Oh no, the LM1889N is getting 20 volts. So, there's a clue there. It's like the 5 volts has disappeared. And I think that affects how the transistors can't start or turn on too hard when the 5 volts is not there. The 5 volt is coming straight from the Traco, so let's get that out. Finally, let's take that out and see what we're dealing with. I don't predict that this is going to be much fun. I'm sure this is fine. It's just that there are traces top and bottom. And for instance, that ground trace needs to be connected both sides, and it might not be. Right, so I have found a problem. This center pin on here is the ground, and that is supposed to be connected to this trace here. So if I check this trace and I'm going to touch this is the modulator, the other side of the modulator, okay, is ground. That's connected. So this is connected here. There's a trace there connecting this pad. That should be connected to the modulator as well. And that is the ground coming straight off of the input of the DC voltage. That's been ripped. So there's no trace there. This pad doesn't matter. There's no trace on this side. This one matters, but that is connected. Oh, I'm going to check that one as well. But this one needs to be connected through. So I'm going to have to run a bodge wire over here through this hole and to the other side to connect these two sides together. I'm pretty confident that's the problem. I'll just put a component leg there, which I'll attach to this side. Actually, no, I need to get the traco in there as well as that. Might not fit. No, that's not going to fit. That's okay, I can do it on this side. Right, let's stick this back in. Exactly how it was. So that should be connected to there. That is. That is definitely connected to there anyway, but that should be connected to there, and it's not. Right, there's the problem. Right, I stuck some heat shrink tubing on the end of this just to give me a little bit more room, a bit of protection. Proper jumper wire. Now it should be okay. I can't see why it wouldn't. That still looks very bright. Let's just check that that is connected. Yeah, that is connected now. 12 volts. 5 volts. Minus 5 volts. It's working. We've got proper voltages. All right, feel a bit safer about putting this ULA back in now, although it's not going in. These sockets are so bad. Right. Oh, we've got activity. Oh, we've got no speaker, so it's not going to do the beep, beep, beep thing. Let's get some capture going. Anything on capture? Yes, we got a screen. I mean, it's knackered, but the CPU might be running. Right, so the CPU is definitely run because the diagnostics is completed and come up with no memory. All right, we are one step closer to fixing this. Oh, I've enjoyed this one. This has been fun. Right, I think for this one, a sensible thing to do would be to put in one of these lower RAM boards. So I'm not using blue tack and I'm not using blue tape. I'm going to use my finger because I need these to be right up against the board, otherwise they won't line up. And they need to line up because if they don't, that RAM board won't go in. Okay, now looking straight down there, all of those sockets, it's very difficult to see on the camera, but they are in perfect alignment. So I just got to solder up all of these pins. Right, the only downside, I can't remember where I bought this from, but the only downside that I find with these boards is it uses the normal pins, the normal 2.54mm pitch pins that you get in things like pin headers. It's the same thing. Now, that's fine, but they don't really go very well in these sockets. They would be better if they were 10 pin for this sort of thing. They will go in, but they will struggle to come back out if there's a problem. That's just the way it is. They have actually gone in really well, and if the sockets aren't aligned very well, then you will get problems with this fitting in. It won't go in. Right, let's try it. Ooh. We've got no speaker still, but we can fix that in a minute. The output's a bit ropey because the socket on the ULA on the modulator is a bit cruddy. Look at this. Oh, this thing's a champion. It took 20 volts and survived. That's how robust these Dash 7 ULAs are. If that was a, I mean, it wasn't 20 volts on the 5 volt line, but the 5 volt line was getting like 8 something volts. And an earlier ULA would have just melted straight away. No question. Okay, so just a speaker. That's all we need now. And a lid for the modulator. Which speaker does this one use? It needs a 40 ohm speaker. That's a 200. Here we go. This is a brand new speaker. I've had this for ages. Oh, still got the pins in. Got to do this with braid. It's going to reflow those because cutting those thick pins can fracture the solder. Now do we get any sound? I'm not going to plug it into video. No sound. No sound. Okay, that's mildly upsetting. It's working. Huh? That wasn't working. That was definitely not working. I don't know. I am quite confused about that. Right, so I'm going to put it back in this case for now. Just because it's got, I want to see if the membrane works in this case, because that could be useful for another computer. Oh, we've got half a keyboard. I'm not going to comment on what I feel about this keyboard, Carsten. But this one's really dirty and disgusting. Could just need trimming. We can try that. it's always worth a go just to take off a few mil off the end. Probably not even 2 mil, probably 1.5 mil. That's 1. You can always take more off. You can't put it on. No, same problem. Membrane's knackered. Okay, so that one I think is as far as I'm going to take this one. This board might find its way into a different case, or it depends what Paul wants to do. He can. I've not seen a plastic back on these before. That's weird. It's usually a metal one. Anyway, whatever went wrong with this, whether it could have been reverse polarity, someone put the wrong power supply in and killed TR4, which then took out the most of the lower memory. It could have been the copper shielding that they put in here for whatever reason that shorted things out. I mean, the speaker was gone as well. That would have had pins sticking through quite hard onto that copper. That was just a bad idea. Oh, I need to change that earplug as well. That I'll do that before I send it back. But yeah, this one, I'm going to call this one fixed and finish this video here. It's had its recap. It's had a whole bank of lower memory fitted with new sockets. The Traco trace repair there. Did I say the recap? It's going to get a new can there. Might even change the transistors here so it's got a slightly brighter display. And that will be all that this one needs. Yeah, I did enjoy that one. It's always a bit of a worry going into a machine that somebody else has worked on before, because you don't know what, I mean, that's not your everyday sort of fault with that trace repair. Breaking that trace was what killed this computer. So you don't know what you're going to find when somebody else has already been in there. You're not sure what their level of competency is, and you could be cleaning up quite a mess. It wasn't too bad. I mean, those voltage regulators are tough to get out. I have taken pads out doing that in the past myself. There are easier ways of doing it so you don't do that, but it is tricky for a beginner. It would be a tricky thing. Yeah, this doesn't sit on the ground. This case is wrecked. Anyway, thank you for watching. I'll see you in the next one. That was fun. I enjoyed that.